Chapter 10. Sound. Introduction. How can you find out when a period at school is over? When someone knocks on your door or the doorbell rings, you can usually tell that someone is there. Usually, you can tell someone is coming up to you only by hearing their footfall. Perhaps you've engaged in a game of hide and seek. In this game, a player must catch the remaining players while wearing a blindfold. How does the person wearing a blindfold determine which player is closest to her or him? We all rely heavily on sound in our daily lives. It facilitates communication between us. There are many different sounds around us. Make a list of the noises you hear around you. You can hear the sounds made by musical instruments like the flute, tabla, harmonium, and other ones in your school's music room. How does sound get made? How is it transported from one location to another? How do humans perceive sound? Why do some noises ring out louder than others? These issues will be covered in this chapter. Sound is produced by a vibrating body. Have you ever stroked your throat while speaking or placed your palm on a speaker of a music system while it was playing? Did you notice any trembling? You must have noticed while doing so that the body was moving back and forth or to and fro, creating sound. We refer to an object as vibrating when it swiftly swings back and forth. When anything vibrates, sound is created. A rapid back and forth movement of a particle or item around a fixed place is referred to as a vibration. Although most vibrations are too small for us to perceive, in rare circumstances they can be plainly seen by humans. But we can sense it. Various techniques can be used to make sound. 1. By vibrating strings, stretched string vibrations can create sound. The metal strings, for instance, are firmly fixed between two locations of a guitar. Stretched strings begin vibrating and producing sound when they are plucked or bowed. To vibrating membranes, some musical instruments create sound by causing thin, stretched membranes to vibrate. For instance, a thin membrane is fastened firmly over it in a drum. The stretched membrane, or skin, of the drum begins vibrating as we strike it, creating sound. 3. By causing air columns to vibrate, some musical instruments create sound by causing the air columns inside of them to vibrate. For instance, the vibrations of the air column contained in the flute tube create the sound of a flute, bansuri. 4. Vibrating plates. Some musical instruments produce sound by causing heavy plates to vibrate. When we bang plates together, they vibrate and make noise. Jaltarang, as an example. Sound produced by humans. The larynx, often known as the voice box, is the organ in humans that is used to produce sound. At the top of the windpipe, or trachea, in our throat, is where the larynx is situated. Vocal cords are two ligaments found in the larynx, or voice box. In order to allow air to move between the vocal cords, they are stretched over the voice box. As we speak, air flows through the aperture and vibrations in the cords create sound. The vocal cords' corresponding muscles might cause them to become tight or loose. This modifies the sound's quality. The vocal cords are thin and tight when the muscles that attach to them contract, and the voice is high frequency. Conversely, the vocal cords are thick and loose when the muscles are relaxed. As people age, their vocal frequency shifts. Since their vocal cords are shorter than those of men, women and children have higher voice frequencies. Sound needs a medium to travel. Ever pondered how a friend who is far away may hear you when you're speaking? This occurs as a result of sound waves vibrating the molecules in the medium around the sound producing device. This implies that in order for a sound wave to propagate and be perceived, it needs a medium, such as a solid, liquid, or gas. Since there are no molecules in a vacuum to vibrate and transmit sound waves, sound cannot travel through it. For sound to reach our ears from its source, a medium such as air, water, wood, etc., is required. To have a better understanding, let us engage in a few tasks. From the above activity, it is clear that sound can travel in air. We also know that sound can travel through solids like wood, metals, bricks, stone, glass, threads, etc. Let us demonstrate this with the help of an activity. Sound can also travel through liquids. Let us perform an activity to show that sound travels through liquids. We hear sound through our ears. The sound waves produced by an object travel in all directions. While traveling, these waves keep losing energy and ultimately die out. When these waves reach our ears, we are able to hear sounds. Let us learn how our ears help us to listen. Our ears have three parts. 1. Outer ear. The outer ear is made up of the ear flaps and ear canal. Ear flaps or pineal are made up of skin and cartilage and are the only parts visible. The pineal collects the sound and transfers it to the ear canal. Animals like cows, dogs and horses have bigger ear flaps, so they can hear more than us. The ear canal is a tube connected to the ear flaps. The sound travels through this canal to the eardrum. Eardrum is a stretched membrane at the end of the ear canal. It separates the outer ear from the middle ear. When the sound hits the eardrum, it vibrates. 2. Middle ear. Middle ear consists of three very small bones. These are hammer, anvil and stirrup. When the eardrum vibrates, it transfers the vibrations to hammer. Hammer transfers them to anvil, which in turn transfers it to stirrup. These bones make the vibrations larger. 3. Inner ear. The inner ear consists of a coiled canal-like structure called cochlea. It is linked to the stirrup and is filled with fluid. It contains many hair-like cells. These cells are linked to the auditory nerves. When the stirrup vibrates, the waves move to cochlea. When the waves move through the liquid, the hair cells transmit them to the brain through the auditory nerves. The brain then interprets the sound. The cochlea is also the organ which controls our balance. When you spin for some time and then stop, you feel dizzy. This is because the liquid inside the cochlea keeps moving for some time after you stop. To understand what the eardrum does, let us do this activity through a Tinken model of the eardrum. Taking care of ears, you should never insert any pointed object inside your ear to clean. This may damage the eardrum. The ears should be cleaned only from outside. The wax inside the ear traps the dust particles and also saves the ear from harmful microorganisms. Characteristics of sound. Sound travels through a medium in the form of compressions and rarefactions. These are collectively called sound waves. Sound waves have some characteristic properties which are as follows. 1. Amplitude. It is the measure of intensity of sound. A large amplitude means a loud sound and small amplitude means soft sound. It is actually the measure of change in pressure in a compression or rarefaction. 2. Wavelength. It is the distance from one compression to the next or the distance of between one rarefaction to the next. One wavelength makes one wave of sound and it constitutes one compression and one rarefaction. 3. Frequency. It is the number of sound waves passing a point in 1 second. It is measured in a unit called hertz, or cycles second. For example, if 100 sound waves pass a point in 1s, its frequency will be 100 hertz. 4. Pitch. Pitch of a sound wave determines how it sounds to our ears. A bird chirping is a high-pitched sound, whereas a lion's roar is low-pitched sound. The higher notes on a keyboard produce a high-pitched sound, whereas lower notes produce low-pitched sound. Pitch depends on frequency. A high-pitched sound has high frequency, whereas a low-pitched sound has lower frequency. A sound with high pitch is shrill, whereas a sound with low pitch is dull. 5. Loudness. Loudness depends on the amplitude of sound. Higher the amplitude, louder is the sound as it has more energy. 6. Timbre. Timbre or quality of a sound wave is the property that helps us to distinguish between different sounds. How do you make out your mother's voice from your sister's? How do you differentiate between the sounds of a guitar and a keyboard? This is possible because of timbre of the sound. Different objects produce sounds of different quality. This happens because a sound made by an object is a mixture of sounds of different frequencies which we hear collectively. These frequencies may have different loudness, which helps us to identify the sounds. Audible and inaudible sound. Our ears can hear sound waves of frequency range 20 to 20,000 Hz. The sound waves with frequency lower than 20 Hz are called infrasonic waves. The sound waves with frequency more than 20,000 Hz are called ultrasonic waves or ultrasound. Animals can hear ultrasonic waves of more than 20,000 Hz frequency. This is the reason they are more alert than us. Reflection of sound echo. Reflection of sound waves from a surface creates what we know as echo. Stand in an empty room and call out your name loudly. You will hear the echo within a very short time. Echo is produced when sound waves produced by an object hit another surface and reflect back. However, for us to hear an echo separately from the original sound, there should be a time gap of 0.15 s. The brain cannot differentiate between two sounds if the time gap between them is less than 0.1 s. For this reason, echo is clearer when the reflecting surface is at a long distance. Applications of echo. Echo sounding has various applications in our life. One of the main uses of echo sounding is in medical industry. Another application of echo sounding is to measure the depth of water in a water body. Ultrasounds are released in water and they reflect back from the bed of the water body. From the time taken by sound to travel back and the speed of sound in water, the depth can be calculated. Absorption of sound. Wherever sound waves hit a surface, a part of them is absorbed. Talk in an empty room, your voice will echo, but if the room is furnished, it doesn't echo. This is because the curtains, carpets, wooden cupboards and clothes absorb sound. Such soft materials are used to cover the walls to stop the reflection of sound. Music and noise. About air pollution, you are well aware. Air pollution is the presence of unwelcome gases and particles in the atmosphere. Similar to this, noise pollution is the presence of excessive or undesirable sounds in the environment. Can you name a few noise pollution sources? The noises of moving cars, explosions, including fireworks, machineries, loudspeakers, etc. are major sources of noise pollution. What domestic sources might produce noise? Air conditioners, Some kitchen appliances, desert coolers, and transistor radios played at high volume all contribute to noise pollution. The sounds that create a pleasant sensation in the ears are called musical sound. It is produced by regular vibrations. Sound produced by a harmonium and sitar is musical sound. In fact, all the musical instruments like guitar, flute, piano, tabla, etc., produce musical sound. However, if musical sound becomes too loud, it would become noise. Harmful effects of noise pollution. Do you realize that having a lot of noise around you might lead to a lot of health issues? Noise pollution can contribute to insomnia, high blood pressure, anxiety, and many other health issues. Continuous loud noise exposure can cause temporary or even permanent hearing loss in a person. Measures to reduce noise pollution. We must manage the sources of noise if we are to regulate the noise. How is this accomplished? Silencing devices must be put in home appliances, industrial machinery, transportation vehicles, and aircraft engines to do this. How might noise pollution in a residential neighborhood be reduced? Any loud operations need to be carried out away from any residential areas. Industries that produce noise should be located distant from these locations. The use of car horns should be kept to a minimum. The volume of the TV and music systems should be kept low. To reduce the detrimental impacts of noise pollution, trees must be planted beside roads and around buildings. This will reduce the amount of noise that reaches the locals. In a nutshell, sound waves are produced by to and fro movement of objects. Sound waves need a medium to travel. Sound waves travel by means of compressions and rarefactions. Sound travels with different speeds in different media. Loudness of sound is determined by the amplitude of sound wave. It is the measure of change in pressure in a compression or rarefaction of a sound wave. Frequency of a sound wave is the number of compressions and rarefactions passing through a point. In human beings, hearing range is 20 Hz to 20,000 Hz. A sound wave with high pitch has high frequency and sounds shrill. A sound wave with low pitch sounds dull and has low frequency. Timbre is the quality of sound that helps us distinguish between sounds made by different sources. There are three parts of human ear. Sound travels from the outer ear to the middle ear and then to the inner ear, from where it is transmitted to the brain. An echo is produced by reflection of sound from a hard surface. Soft surfaces like clothes, curtains, sand, etc. are good absorbers of sound. Excessive sound in the atmosphere is called noise pollution.